I'm Alex, and this is the second of a three-part video series covering the creation of a game I worked on recently called Tombworld. Tombworld is a 3D Metroidvania-style game made in the Godot game engine in 1 month for a recent game jam. In the first part of this video series, I played through the game and talked through the different design decisions we made as we worked on the game. In this second video, I'm going to start diving into the code. I'm going to open up the Godot editor. We're going to start with a high-level overview of the architecture of the game, and then we're going to drill into individual features that make up like the backbone of that architecture and slowly wind our way down to the more and more minor features. I hope this is going to be interesting for people, so enjoy. Thank you for watching. Good luck. All right, so we finished the first half of this video. We've played through the game from beginning to end. We've seen the different design decisions that were made along the way, and we've seen how almost every feature that made into the game manifests in the game. Now we're going to flip around to the back side of things. We're going to see how the game was architected, and we're going to see how the individual pieces were made. So we can see how something like navigation was designed, and we can see how it plugs into the game itself. I'm generally thinking the order of this will be an overview of like the code layout, dive into the different like main processes that actually like bootstraps the game. I'll look at how save files work, and then we'll get into individual features. So I think I'm going to start with how levels are like loaded when you go through a door. Then I'm going to talk about how different entities work, things like elevators. Then I'm going to talk about how enemies work. So both how they do pathfinding and how their behavior tree works when they choose to shoot you. And then we'll get into more. I'll touch on how the player works briefly, but the player was largely implemented by Tyler, so I don't quite have such like deep insights into how the platforming, how the player motion and like looking around works. But should be understandable nonetheless. What else would I want to talk about beyond those things? I think that's basically it. I might open up Blender at the end of this and offer a couple of bits of advice on Blender and advice on how to import from Blender to Godot. I also have some thoughts on how our 2D art import pipeline worked because it had some issues. And then I think that's going to be about everything I want to cover. I might cover how I put together levels. Anyways, once we're done talking about enemies, we'll see how much time is left in the video. So to talk about how this project is architected, generally speaking, you can see in the file manager if you clone the Tombworld public repo. So this is, by the way, the code is online and publicly available. You can clone the repo if you like and look at it. And when you clone it, you're going to see there's a license file, a README, and then the project folder. And then everything that's important is inside this project folder. The root of every Godot project is a project.godot file. And then within that project is a number of whatever assets, your scripts, or your art that you need, plus these tscene files. And so Godot breaks a project up into scenes. And scenes are all these like homo-iconic, like main is a scene, it's the thing that everything gets added to. They're these trees of nodes that could either represent something very small, like a platform, or something very large, like an entire level or an entire game. But they're all structured the same. They're all like the same thing. You can make an instance of a scene in another scene. And so Godot uses those as its building blocks. And so you can see a lot of tscene files in here. And I think tscene stands for text scene because they're all just text files. You can like open them, edit them. It makes git merges really easy because if I change like margin top to something and another developer changes it, you get to see textually your merge, which is nice. Excuse me. It's fall has come and you can hear how stuffed up I am. So that's going to color this video. I'm sorry about that. Next time I'll film this video in the height of summer, I suppose. But yeah, that's kind of the general breakdown of the project is there's a Godot file and a series of scenes in the Godot file. And so we can see the same thing here is the Godot editor. And we get our file system view, which matches very closely the actual file system on disk with import like metadata files excluded. We get a tree here. So this tree corresponds to the currently open scene. If we open a new scene, we get a new tree. So yeah, there's some other tree. That's actually from a plugin, but still. And then each node in the tree has a set of properties, and those properties are hierarchical. So every node has a set of node properties, but only, like this is a control. So it has canvas item because a control is a canvas item, and then it has its control properties. And so you can kind of see like if you ever look at an object, its most specific properties are up here at the top, and they get more and more general as you go down until you get your node properties, which every node has. Yeah, so that's generally how this is laid out. There's a little bit of weirdness. If this is your first time seeing Godot, I'll talk quickly about how these tabs work. So if you have two T scenes open, every T scene you open, ooh, this is from a plugin. Anyways, every T scene you open appears as a tab up here. And whenever you select a T scene, the focused scene, its scene tree appears in this scene viewer. And like obviously whichever node you select, its properties appear over here. Each scene, so this bar of 2D mode, 3D mode, script mode, asset lib is something totally different. There's no reason it should be in this bar. But the other three, 2D, 3D, and script, are specific to a tab. So if I go to this tab, it's in 3D mode. I go to this tab, it's in 2D mode. This visual hierarchy is like, it's backwards. These 2D and 3D should be below the tabs because changing tabs changes modes. The same is true of individual scripts. So I put both of these tabs into script mode, and then I open script, say global on this tab, and then I go back to this tab, the active script changes. So each of these tabs has a different active script associated with it. It should. I'm not sure what's happening now. Typically when you switch tabs, yes, that went to main. This should go back to global. Maybe because this is from a plugin, it's not behaving right. But typically when you change tabs, it will change your script. So that's the layout of those tabs. So now I'm going to close all these open, like, scripts. And we can talk about the layout of this project. So at the root of the project, we have a couple of files. Most importantly, the main T scene, the main GD script, and the global GD script. And then as children of this folder, we have all of the like sub features of the game. So the different add-ons that I have installed, the assets, which is all the like art and 3D modeling assets, sequestered into their own folder. Our audio assets get a folder. Entities are things like bullets, elevators, enemies. Anything that moves around a level that isn't the player goes into entities. Notably, there's this filler folder, which is all the entities that just are totally not interactive. So stuff like vases that you just like, it's just throw them into the level. They're clutter. They make the level feel full. That stuff goes in filler. Then we have our different guns. So each gun has a T scene and a script attached to it. I'll point out. So, okay. And then we have our menus. So all those different pause menu, victory screen, load menu, all that goes in here. The victory screen is vestigial. We don't use it. But all the rest of those menus credits all go in here. The player itself gets a folder, which is pretty sparsely populated. There's a scene for the player, and a script for the player, and a script to control what gun you have active. Then we have a folder full of stages. So these are like, not like entities fill up stages, right? So like this is that stage, second to last stage in the game that you kind of platform through. You can see there's only like those two clouds meant to be seen through this portal here. And so this is the stage, and all of the stages go in the stages folder. We've got a testing folder, which has like, I just built small little T scenes that I use to prove out certain features. I might or might not actually commit them, but they go in the testing folder. And so this was a testing scene to prove out how navigation meshes work. Yeah. And then we have a UI folder, which is all the different like little UI widgets. So stuff like nope. So this is the whole dialogue progression thing that like it shows dialogue from the bottom, it scrolls up as you show more dialogue. Our font is in here. The volume slider's in here. So all the little UI widgets end up in here. And there's a utilities folder for like little things. Stuff like we have a script that turns on and off lights as the player gets close to them because Godot can only show 8 lights on a single mesh, and so we like to only have the 8 lights closest to the player turned on. This didn't ship in the final game because sometimes this doesn't matter, and on some platforms it does. It was strange. So we didn't end up turning it on because it was very awkward to only be able to have 8 lights, and as long as the lights are all hitting different meshes, it doesn't matter. But in testing, we had one giant mesh, and so all the lights hit that giant mesh, and then it looked very bad, so we would turn off the faraway lights, and things were a little bit better. But all these like miscellaneous things, like there's some text manipulation for like left pad, right pad. There's this like text 3D node in here for showing like loading text in the scene. Right, and you can just edit it on the fly. So we've got like just little utility things like that. All right, so that's the general layout of the project. So then I want to address how the project actually starts up. There's a setting in Godot where we say in project settings, general, where is this? Auto load? Oops. Come on. Here we go. So in application run, there's a certain T scene specified, and that's the first T scene. It will be loaded automatically by the game. So first, that's main.tc. So we can look at, okay, when the game starts, what happens? That script, that scene gets loaded, this scene gets loaded. And so we can look at the scene here and wonder what happens. So every node, remember how I said nodes are hierarchical? This is a control, but more generally it's a canvas item, and more generally it's a node. Well, every node can have a script attached to it. So you can attach a script to it, save the script to your file system, and you can see in here that this script is attached to the node. So when this scene gets loaded, this script also gets loaded. As a slight diversion, I think it would be really nice if Godot let you save scripts inside of a tscene file. So remember how this tscene file is just a text file? Like, there could be a script embedded in the text file. In the same way that, like, most resources in Godot can be embedded in a tscene file, but scripts can't. So, for whatever reason, every script needs to exist on the file system outside of a tscene file. And yet, 99% of the time, you won't attach a script to more than one node. Like, it's almost always the case that scripts exist one-to-one with a node. There's a main tscene, there's a main.gd. That correlation is really tight almost all the time, and so it's a little unfortunate that you need to clutter up your file system with a separate script. But you can see by clicking on main that when Godot starts up, this is the script that it's going to be running. And most importantly, there's this ready function, which is the script that gets run when a node is added to the scene tree. So when, in this case, Godot auto-loads it, we're going to do these different actions. This does have a physics process event, so the other two really common events in Godot, maybe three, are right here. There's a process event, which happens basically once a frame. There's a physics process that happens once every physics frame, if your physics and game frames aren't in lockstep. And then there's an input function that happens whenever like a keyboard input or a mouse movement event occurs. And so we're doing a little bit with that in main, but it's pretty minimal. There's a sibling class to main, though, that's quite a bit bigger. It's called global. It's also in the root of the project, and it's bound to this variable g. So anywhere you see g period, that's us accessing the global script. And that script is also automatically loaded by Godot, but it's not like our root script. It's like this bonus script. If you go into settings and say auto load, we tell it to automatically load global and bind it to the variable g. And we just expose a lot of simple functionality on this. A lot of things like, in Godot, if you want to make a vector 3, you would do var v equals vector 3, 0, 0, 0, or I mean 0, 0, 0, something like this, right? Where like you want to make a simple vector 3, and that's a little bit verbose. So there's a var v equals g.v3 0.1, and that's going to does the exact same code for you, right? I don't know why you're unhappy. Oh, is v2. Yeah. So that does the same thing. So there's just a ton of these little utility scripts in global that it could all be farmed out to different like individual helper scripts, but at some point, like making 30 helper scripts and like assigning them all here, it seemed easier to just make one global script and then make all our little helper scripts children of global. So yeah, so there's global there. And main kind of does a little bit of a knitting on global's behalf. So the global data tables gets created in main and added to the scene tree, and then global has a reference to that like table. Similarly, like the global, we get some debug info, developer configuration data from global, and then this acts on the developer configuration. But like between main and global, we do all of our initial setup, and all the like active setup is driven from main. Global is just like a stupid container to hold the configuration that main does. So we can look at global quickly. It has references to most of these root nodes. So if anywhere in the game you want a reference to like game or to guns overlay, you can just do like g.guns overlay and get that node. And so we've got all those references. It tracks game time, which is nice. That just gets updated in main every frame. And it doesn't track overall like milliseconds since the application started. And that's sometimes useful to know. So we just incrementally add up all the deltas that Godot gives us, and that gives us the overall elapsed game time. Then, like I said, there's just a lot of little helper functions in global. There's also, for the most part, they're helper functions. A couple of them are truly like canonically important to the game itself. So things like displaying a menu, clearing a menu gets called in global so that everyone can like do it. So whoever needs to pop up a pause menu can just like ask global to pop up that specific menu. And to talk quickly about the layout of, so main is the T scene, but within the T scene we have a tree of nodes. And these nodes are meant to just be like layers, right? So game is on the bottom, and then utils is on the very, well, debug is on the very top, really. And the idea is that like the 3D game world, every stage is going to be a child of game. Whatever guns are visible are going to be shown in the guns overlay. So like the actual like the kind of big gun in the middle of the screen, that goes in the gun overlay. But then above the, and that always goes on top of the game world. So enemies can't draw on top of the gun overlay. The gun overlay is always on top of game. Similarly, guns can't draw on top of stats. Stats are always on top of guns. So things like your gun can't accidentally cover up your health bar because the health bar is part of stats. Again, like layering, menus go on top of stats. So your pause menu always covers up your health bar. And then layering again, your dialog always covers up your pause menu, because if you open dialog from the pause menu, you have to see it on top of the pause menu. And finally, we have a debug overlay, which has like logs streamed onto the screen directly. So instead of sending logs to this output, you can just get them on screen, which is a little bit more helpful. And there's some other stuff in debug to make it easier, like show a value that's changing very quickly over time, because in game engines that happens a lot, right? Where like the player's position changes very rapidly, and you don't want like 5,000 log messages. So instead it has a little utility that lets you say, show player health, its current value is this. And then every frame when player health changes, we say, this is still the player's health. Can you show it in the same place? And they'll overwrite the same spot. So you just see like the value change over time. So yeah, that's kind of the structure of the main. And that's how the game starts up, right? Main calls. Right. The last thing to say about how the game starts up is in here, there's two possibilities. There's a config file we look at, and if the config file says to automatically load a level, we'll automatically load that save file. And if it doesn't say to automatically load a level, we will go to the main menu. So by default, this is right here. We say global load main menu, and that's going to load main menu. And that's really just to wrap around load the first stage, which is the main menu stage showing the main menu. And that gets called in a few places, so we have this like helpful wrapper, so you don't have to do load first stage, blah, 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 blah. Main menu stage, null, main menu. So yeah, that's kind of how the game starts up, is that you're going to see the main menu first, and this is why. And once the main menu is there, you have a button. That button's going to, you're going to click the button, it's going to call into global. That's going to say load first stage again, I believe, and it's going to say, well, no, actually, all it does is it's going to, I'll show you. Menu. Here's our script. When you click on start, we just do g.load menu, load menu. Okay, so it's the load screen. We want to load the load screen, which is named load menu. And so all of these like g.load menu, menus have to be in this menus folder, because this name load menu is going to be, I've said that word too many times, and now I've got like, it doesn't feel like a real word on my tongue anymore. So load menu corresponds to this name load menu. If you ever call g.load menu with a string that's not real, no. right? That's not one of these file names. The game's going to blow up on you. And similarly, credits just load menu credits. And then what that does is global's going to delete whatever's currently in the menu and overwrite it with whatever menu you just asked to load. So yeah, we clear out the current menu. Then we get the menu root. And then we load our new menu and add it as a child. And then we free the mouse if needed. Because in a first-person shooter, the mouse is like hidden and locked to the middle of the screen at all times. And we don't want that when menus are open, so we figure out if the mouse should be locked or not. So that's kind of the root of the game. And then the thing to talk about is save file. Or before I talk about save files exactly, you'll remember I said here we're loading this config and deciding if we should auto-load a level. The deal is that when you're debunking a game and you have this like prescriptive, there's two ways you can build a game. You can like be prescriptive and say, okay, we always load main.tscene first. It has a bunch of utilities at its root, and all of its children can call into those utilities. That's one way to structure a game. The other way to structure is to say, it sucks to have to load main first and like have all these, because now the child expects I must be a child of main in order to do what I do, because they're like going to look up the tree to find their parent. And so now you're stuck with all these child scenes that like can't be run independently. Like this testing scene was nice because it's standalone, so I can just run the scene and it won't break. But if I open any of these stages and I try to just run this one, like this is the final boss. If I try to just load the final boss fight, it's going to error out because the setup hasn't been done. Main was never loaded. Variables it expects to be defined won't be defined. And so with this project, we chose to err on the side of like, it's really nice to have a bunch of predefined things set up and ready to go for you. So we force you to always enter the game through main, and that gives you the benefit of all that stuff you set up in main is now available to you. But because of that, it means you've got this extra like round trip if you have to go to the main menu, click start, click load game, and really you just want to jump into a scene. So to work around this and like be able to have the like niceness of loading main right up front and having our utilities, but also jump into just the scene we care about, we have this dev config, which is split into two files. So these are like variables each developer might want to set locally. And there's a default config, which is what is loaded like when a production build of the game is run. So do we automatically load a save? No. Do we limit the number of lights that are visible? No. Do we allow debug tools to be turned on? No. That's prod setup. Then we have a dev config. This is ignored from Git, so every developer has their own copy of dev config, and they can overwrite these however they want. So do you want debug tools to be allowed? Obviously, we're doing development. We want to auto-load into save slot number 1. Yeah, we can also auto-load into save slot 2 or save slot 3. And so if I run the game, it should auto-load slot 1, and I should have my debug tools available. Yep, so there's our slot 1. And I can do things like no clip out of the level by pressing J. Cool. So yeah, this little pattern of like a config and then a like local override for each developer is nice. It used to be much larger, actually. There was a lot more settings, and all those settings got pushed into the save file, which means it's basically time to talk about the save file now. So yeah, you can just see, we call this debug get dev config, which ultimately is just loading this dev config script, or it's going to check if dev config is available and return the dev config, or if there was no dev config, it'll give back the default dev config. And from there, we can check, was there an auto load slot? Are dev tools allowed? Should we do that limit 8 light thing? And yeah, that's kind of how we inject individual developer settings when needed. So let's look at how saving works, right? Because the first thing, the player hits start, they load a save slot, and then like we pop into whatever that save slot looked like. So let's look at a save file, right? If in main we did g.saves.load save, like we just loaded a save slot, like how does that actually work? So there's a script called saves in utilities, and that has a load slot function. So we gave it our slot name, and then we check that there's a utility to see, does the save file exist under this name? If it does, we load it. Otherwise, we just start a new game, and we've overwritten our active save slot. So later, if we call, there's a save game function, right? Save. Save data. I don't remember what. Yeah, there it is. It's just called save. So if you call this save function, it uses whatever the current slot by default. Or yeah, if you don't tell it a save slot name explicitly, it'll use the default one. So when we do the load, we set our current save slot, and then when we do the save, we use whatever slot was active. So yeah, now we kind of have the knowledge we need to go look at a save file, which all exist in a folder. Maybe we don't have the knowledge we need, because we would want to know what folder do these save files actually go in. So yeah, so when we load a save slot, we check if the save exists, which means we had a list of all the save files, and we check if that name is in the list, which means we need to get a list of save files, which means we're going into this users folder, which is every Godot game has access to this user : folder, which is data persisted to disk, and you can just put whatever you want in that folder. And you can get to that folder from the editor by hitting project, open project data folder, and then there it is. That's your data folder. And you can see like there's the saves folder. And so I just have that one save slot from the playthrough we just saw. And I can open that up. And there's a save file from Tombworld. It's just JSON. Great. And so what we're doing here is we're listing all the files in the save file. We're ignoring dot and dot dot, which like are shortcuts for like current directory and parent directory. We're removing the JSON from the end, and those are all of our save file names. And so, you know, when we look to see if a save file exists, we're getting that list of names, and we're checking if whatever name we were given is in there. There's also this helper function. If you remember in the load screen, below each save slot, it says the name of the level you're on. That's just being done by cleaning up the name of the currently saved stage in the file. So if you look here, like wherever we checkpointed is like entryway dash the throne room, and this cleanup function is like stripping off entryway, removing the underscores, and then like that's the cleaned up name for each room. You would probably want to have like a real room name separate in a bigger game, but for us this was fine. Anyway, so let's look at the save file. There's 3 layers to the save file, really. There's this outer layer, right, where we have a version number and then a data array. This is vestigial code. This structure didn't end up being useful for us, but I'll explain what it was designed for. The idea was that you would have a bunch of, see how data is an array and not a dictionary? You would have a list of different nodes in Godot that wanted their content saved, and you would save each of them as an individual entry in this list. So like right now we just have, what I'm trying to do is clear out the data, make it a little more demoable. So right now we just have the main save, which corresponds to the main.gd script. It has this like get save data, load save data. So when the save system decides it's time to save, it goes out and finds everyone who is tagged as savable, and it calls their get save data function. And this is supposed to give a like serialized data object that can be persisted to disk, which you see is actually what happens, right? That's this data here was all serialized right here. The thing I thought I would do was have a list of dependencies, so I could do this for multiple nodes. So any node that cared about being saved would be like, I need to be saved, but I can't really be loaded until someone else is loaded. So you would have like, I don't know, room 1 would be something else that saves. And room 1 is like, I can't do my thing until main is done. So it would say, I have a dependency on main. Then when loading happened, it would find, okay, here's main. He has no dependencies. Get him done. Then go on and do whatever comes next. That's room 1 because his dependency is now satisfied. And it would go through and like apply all of these different save configs in the right order. The problem came in that I wanted to do all this application right when the save file loads. Like, save file loads, hand off the data, then the save system is totally stateless. This fails because in this game you go from room to room to room. So you want to have save data about room 5, but you saved in room 1. So room 5 can't accept that data from the save system until it actually exists. So the save system would have to like hold all of this state, see when a room is loaded, give the room its state when it starts up, which is all like, I think, a very cool idea, and I would like to do it in a game at some point. But the practical reality was just that like building that system where we like wait for rooms to load, it was needlessly complicated for a project of this size. What I ended up doing is that the only like entry in this array is always main. And main has all the save data for the whole game in it. So everything we care about is in main's data object. Okay. So what's in main's data object? There's kind of, as I said, there's 3 layers to this. So the outer layer, this vestigial version stuff, we're kind of going to ignore. We're going to step into just this main block. And now the main block, what we really care about in here is the data in the block, right? And so that data, now we're kind of getting onto layer 2. It has these 4 properties, like we saw: stage, menu, save point, and game state. So the first 3 are kind of simple. The stage is whichever stage the player is currently in. In the case of the save file, they were in the throne room, which corresponds exactly to stages, entryway, the throne room, right? So whatever T scene, the path from stages is what gets put into the save file. Whatever menu you have open. So if you had the pause menu open when you saved somehow, that would be stored, and when you reloaded, that menu would be opened up again. And then whatever save point you're at. So some rooms could have, a save point on one end and a save point on the other end. And when you reload, we need to know which save point to place you at. So we store the save point name here. All right, cool. So all this outer stuff is all about reloading the player back to the right position. So then, as I said, there's like a third layer that's game state. This is all the like stuff, the like state of the game, like what rooms the player has gotten through, what they haven't gotten through, what guns they have, that sort of thing, how much health they have. So packed into here is a combination of player stats and then information about like individual assets. So like every elevator tracks if it's at the top or at the bottom and just saves that to disk. It's a utility to make sure. I don't really care about persisting elevator position, right? That's kind of pedantic. It could just start at the top every time. The problem is I need the player. I want the elevator to spawn on whichever end the player is on. So if they're on the bottom, I want the elevator to be on the bottom. If they're on the top, I want it to be on the top. Instead of writing logic to figure out, like, is their y-axis greater than the midpoint of the elevator shaft or whatever, I just figured I would save wherever the elevator was. So I start every elevator where it's most logical for it to be, and whenever the player uses it, I just persist where it went to. So if they go to the bottom, it'll stay at the bottom, because that's probably where they're going to come back to it. Similarly, like item pickups, so all of those different like pedestals that had like different either like health pickups or the movement abilities, those are all stored here. So once you clear them, this goes to like empty quotes. So whenever the pedestal loads up, it checks, am I supposed to be displaying something? And the empty quotes tell it, no, I'm not supposed to be displaying something. So by the time this is persisted in memory, these variables actually have like a value, but by the time they're persisted to disk, they're always just an empty string because they've been collected. Sort of a similar setup with gates. Gates can be open or closed, but by the time they're persisted to disk, they're always open. And so this game distinguishes between a door, which is a load between 2 parts of the game, and a gate, which is a like artificial barrier that prevents you from walking to a different part of a level. And so gates are these things that can be opened. Doors don't persist any state. And finally, what else is here? We have, I track cleared, but just for a couple of rooms. So the 2 fight rooms track if they've been cleared or not, because we want to show different enemies if they have been cleared. And finally, there's a variable for show debug overlay, which is if the debug information is currently visible. So there's this split about debug information, right? In dev config, it's if you're allowed to turn it on, and then in the save file, it's if it is currently turned on. Just kind of where those variables ended up. And finally, all of the player stats are in this stats block. So how much health they have, how many tanks they have, their maximum tanks, what guns they've got, what abilities they have, jump, glide, dash, scanner, 4-color, slime. This is like the save file from the end of a playthrough. Here's all the different lore entries we scanned. So when you scan something, after the scan is complete, it gets added to this list of lore entries, right, in the game state. So that's kind of nice, and that way they get displayed in the right order, and they're persistent when you quit the game and all that. Something to note is you don't really need to store... I store the active gun, and I store the... Well, I guess that's kind of the only critical one. But I store which gun is active. So when you quit and reload, your same gun always pops out as active. I don't know if that's really important. I bet most games don't, but I did. I don't know. Yeah. And then like you can just store separately like how many health tanks you currently have from how many health tanks there are total. I guess I didn't even really need to save this because I could just give the player full health when they respawn, but I ended up saving it to disk anyways. Well, cool. So that's kind of how the save file looks. And so now we can see where it actually like manifests maybe. Or, yeah, that's the save file. And the way that this gets consumed is super simple. Like I said, I thought this will all be injected into nodes, but that's not really the case. So in main, there's this get save data, which is what gets the save data serialized to disk, and then load save data, which is when it comes off of disk, it gets injected into main. And so the injection happens here. Maybe the only... What's important to say here? Data... Where does the game state get loaded from? That's kind of weird. I would have expected game state to get loaded. Ah, I see what's happening. So, load game state. First we build the initial game state. Then we load whatever stage was previously loaded. So we're going to build up all that, like the player's health, the player's current guns, the player's lore entries. That happens here. Then we're going to load a certain stage, and we're going to put you in that stage at the location of your save point. Then if a menu was open, we're going to open up that menu. Right? It's kind of like what I was saying. So let's look at not loading the stage, but looking at how this initial build gets done. So when we do the build, we pass in whatever data was loaded from disk. And so we can actually check, does game state exist? And if game state exists, we just use the game state, and like that's it. Like the g.gamestate is our like in-memory game state. And if it existed on disk, we use it. And if it didn't exist on disk, we need to fill it up. So like if there was no game state on disk, it's an empty dictionary. If it didn't have any stats, we give it these initial stats. If it didn't have any elevators, we make the initial elevators, etc. We make those initial data structures at the root of the save file here. And then game state is all populated up, and anyone can like consume it. So game state is just this property of global, and you'll see g.gamestate gets consumed all over the place. Very popular with the kids. A lot of it, so like, yeah, a weapon pedestal, for instance. When you pick up a like health tank, we give you full health by, setting your we fully heal the player. We give them an extra tank of health. We fill up their extra tank. So just stuff like that, where whatever state there is in the game, you need to back reference to g.gamestate and always like rectify yourself with this, because it might change. It might be changed by someone else. So it's really your job, like in a process function, to make sure you are respecting whatever is now in game state. And in theory, we could have some event emit that says game state was updated, and that way you don't have to check it every frame. But it really wasn't a performance problem for us to just check it, and it was very simple to write that code, so we stuck with that. Okay, cool. So that's kind of saves how they're loaded, how they're consumed, and that should explain how we go from no game running to game running with player in game, and then how we like persist that game to disk, and when you restart the game, how it now like continues to play successfully. So all said, I think the next logical thing to get into is how you actually move through this world. So I'm going to talk about this concept of doors, which are... I'm going to start the game and I'm going to show you how they work in game as a refresher, and then we can go from there. First, I'm going to kill some enemies. Maybe I'll cut this. Probably I won't bother. Okay, cool. So we have a door here. And a doorway is actually a, like, composite of a lot of little pieces. So right now you can see, like, there's nothing behind that door. I just turned on no clip and jumped out of the stage. Yes. So there's nothing behind the door. So there will be something behind the door. We're going to try to go through it. So there's an invisible volume surrounding this door, which if I cross into it, will trigger what's behind the door to load. So let's say I cross into it. We get a little loading hitch, but then what's behind it is loaded. So now if I go into no clip, I can see, cool, both this stage and the plateau stage are loaded, and they're lined up right at this door. All right. So now, if I tried to hit E to open the door before the load was done, the door wouldn't open because there's nothing to show me. But now that the load is done, I can press E, the door will open, and I can just pass through. And if I move far enough away from the door, which in this case means I actually need to go up the elevator shaft in order to, like, get far enough away, the door will close, and what's behind it will be unloaded. So right now, still nothing has been unloaded. But, oh. If I get onto the elevator and go up, that door is going to close. You won't see it, maybe? And the other level is going to unload. So by the time I'm at the top of this thing, there's nothing to see down there. The other stage has been unloaded, and the door is closed. And now the same thing can happen in reverse. If I approach this door, there was a loading hitch about halfway down the elevator. Hit E, it opens. Oh, and it's my friends. Great. And yeah, now if I exit, that other side's going to unload. Great, so that's kind of the logic. So how do we do something like that in Godot? Let me show you quickly a running scene tree, just to be totally clear. This, you can see the remote scene tree. So in the running game, this is our, like, debugs, our development scene tree. But in the running game, we can go to remote. We can see here's main, here's game. There's a child node, throne room, because we're currently in the throne room. But now if I go into this loading zone and load, you can see the plateau popped in. Now there's two. And if I go up the elevator, you're going to see when the plateau pops out. Just to be clear about where those are getting placed in the scene tree. Great. It unloads soon. There it is. So the throne room unloaded. Great. So that's all done with this construct of a doorway. So let's look at the throne room. And we can go and find the doorway in its scene tree. So I made this, like, collection node, doors and gates, and it has all the different, or like doorways and gates. And like I said, doors and gates are kind of different. But I want to find this one specific door. Oh, actually, excuse me for a moment while I rant about something. In order to organize this scene, I made a bunch of spatial nodes to group together common things. So, like, the different, like, items in the room go under one group. The different, like, props, so stuff like vases and, like, clutter filling up the room goes into a different group. And that group's pretty big, but it's, like, unimportant. All the statues are also in there. And so, like, I use these to group. The problem is these spatial nodes apply their transform to their children. So, like, if I were to take props and move it, all the props move together. I don't really care about it. So I thought what I could do, I thought it would be clever, and I would change this into a node, because nodes don't move their children. So I was going to be like, change type node. Great. Now, if I try to move, like, there's not even anything to move. Like, it doesn't make sense. There is no, it's just a node. It's not, like, a spatial, so there's no transform, so I can't, like, drag it around. So I thought, great, problem solved. And then I accidentally moved this, and all the props didn't move with it. And I was like, what is happening? This is not possible. Like, obviously the parent moves, so its children should. And the trick is that this only moves its direct, throne room moves its direct children, and the direct child has to move the children below it. Because this isn't a spatial, it has no idea it's supposed to, like, move its children. So having, like, the ability to move grandchild spatials would be really nice from an organizational level. Like, I want a folder structure. Like, I want, in addition to, like, a spatial node and a node, I want, like, a spatial unpositionable node. I think that would be really helpful. change this back to a spatial. Nope, that broke the game. Cool, so I just did undo, and now the props are laid out how they were supposed to be. When I say it broke the game, I mean this. Apparently props is rotated 180 degrees at some point. And so when I changed it to a node, that rotation was unapplied, and you saw all of the props were like backwards and off to the right, and that's because they like were rotated to 0 basically. So I don't know when this happened, but changing it to a node lost that negative 180, and when I changed it back, it still didn't have it. So just an undo got me back where I wanted to be. Anyways, we were looking at this to talk about doors. That was my quick aside of like a ranty Godot-ism that makes me a little bit crazy. So let's look at doors. Let's go find this door. Oh, another ranty Godot-ism. Nope, we're going to put that off for now. So a door is made up of 3 pieces. There's a doorway, which is a spatial. It's also a t-scene, right? So doorway.tscene is here, and there's its corresponding GD script that another Godot-ism. I can't like embed the GD script, which is annoying. So yeah, there's my doorway. It's completely blank. It just has a script on it. Underneath it, there's a collision shape. And that collision shape is, like I said, there's this volume that tells us when we should load, and that's what the collision shape is. And then underneath it is a door, which is any node with a script on it, and that script needs to extend door. And so as long as this node extends door, the doorway will find it. And it's sort of a dance between these 3 pieces to figure out if a zone should be loaded, right? Because first you have to cross into the collision shape. That's going to load what's behind the door. Once it's loaded, the door is now allowed to open. And all of that logic is done in the doorway script. So now we're going to get in here and look at how the doorway actually works. I'm going to try not to just read code out loud to you, but I'm going to get pretty close. So the first thing this does, though, is expose 2 variables. And when we say export, that means it should be visible in the editor. So we're going to go back to the throne room, and we can see this door, which leads to the plateau, has these 2 variables. It says, when you go through me, I lead to the plateau stage-plateau, and I lead to the labeled door throne plateau 1. And so that just needs to correspond to the plateau stages. Okay, it also has a doorway. And that doorway needs to have that corresponding name, throne plateau 1. So that name matches this name, throne plateau 1. And that's how they know those 2 doors need to spawn right up against each other. And each of these doors leads somewhere else, right? This is the door underneath the staircase, and that leads to the fallen pillars room, and there's a corresponding door by this name. So cool. So that's how we know which door leads to what. And you just, when you create a doorway, it's your job to put in those strings to tell us where it leads, because otherwise the door can't figure out where it goes unless we tell it where it goes. Cool. So, like I said, the general logic here is Godot lets you, there's events that get fired off when a body enters the door, when a body leaves the doorway. They're kind of the like beginning of this door life cycle. And so the door is, if you click on a node in the scene tree, then you go to this node tab. I don't know why it's here and not in the inspector. It seems a little arbitrary, but yeah. So some properties of a node are in the inspector. Some properties of a node are in this node tab. The division is largely arbitrary as far as I can tell, because in truth, groups are a property of a node, and signals they could be coming from any layer of this, but they're definitely part of this class hierarchy as well. But for whatever reason, they have a separate tab, maybe because the UI is a little bit wonky. And you can see body entered. I've told it that should call this script. And that's just stored in like in the tscene file for the doorway. That mapping is stored to call into this script's particular function. So, and they also show us this nice little UI. This little green arrow says, hey, this is on the doorway we call body entered. Cool. So when a player enters, if a stage is loading, we don't do anything. If a stage isn't loading, we ask the system to start loading the stage. If a player exits, we kind of do the opposite. If a stage is loading, we say give up on loading. The player left, they don't care anymore. And then we close the door. There's a catch to when we close the door, though, which I'll get into in a second. It's only if they're on our side. Because they could have opened the door, passed through, and now they've left the volume, and now it's time to close the door and unload the other side. Or they could have entered the volume, decided they don't actually want to go through the door, and exited the volume again. So there's two different possible reasons they'll be exiting a volume. So yeah, so that's the first thing that happens. And then we're telling the door to open by setting this. Well, we're not telling the door to open. We're saying we request a load, and there's this script called stage loader, which is global. We instantiate it in global and like reference it here because every door kind of needs access to the stage loader, and the stage loader is just a threaded thing. In theory, it's a threaded thing. I can talk about why the threading failed for us. I'll try to be quick though. So stage loader, you call this function request load, you call this function cancel load. Those are your two public API calls. The idea is that up until close to the end of development, it worked like this, where you would request a load, you would add a callback function. So the idea is that once we're done loading, we're going to call this function. This is a function reference, so it says call on the self object the onstage loaded function, and that's going to be a callback that gets triggered once the loading is complete. Loading happens asynchronously in the background, so it could take a while. So we just say, whenever you're done, let us know. And if we change our mind, we're going to call cancel, in which case onstage loaded will never be triggered. So cool. Stage loader adds that callback to a dictionary and spawns up a new thread to do the load. And that really has three heavy operations. First, it needs to load from disk, which takes the T scene and just brings it into memory. And that's all. It doesn't really build a node out of it. It just has the T scene as like a big binary blob. Or it's really like, it's just a dictionary of the node tree that could exist and the properties that must be injected into that node tree. And then you make an actual instance. So you say, take that node tree that could exist, actually build it, actually apply all those saved properties to it by calling instance. And then you have this node tree, but it's just floating off in space. And so then we actually tell the stage to load this stage, which means we want it to add the node tree we built floating in space, the actual game tree. So like that's when it gets added into game here. And so in theory, each of these steps, load, instance, and add to tree, are kind of slow. In practice, if there's like 100% of like, we're building up to a 100% load, the first 10% is load from disk. That was startlingly fast. The second 10% is instance. That's also pretty fast. Maybe the second 20% is instance. It's a little bit slower because it's like creating actual nodes. It's talking to the physics system and saying, hey, I've got a physics object I need you to track. Talking to the rendering pipeline and saying, hey, I need you to like create, vertex buffers for all this stuff. And so that setup takes a little bit longer, but shockingly not that long. The place where things really get slow is when you add to the scene tree. That's like 70% of your load. And there's a big warning in Godot's docs that says adding to scene tree can't be done in a background thread. It is unsafe to use the scene tree outside of the main thread. So cool. We did all this work to load in the background, and it turns out that this can and does blow up. So on Linux, it seemed to work fine. On Tyler's computer on Windows, this blew up on us like right away. There were like weird access errors. And so we just decided that we could, in theory, do the load in the instance on a background thread, save ourselves 30% of the load time. But then like the big cost was always adding to the scene tree anyways. So we just switched to, for the sake of stability, we load on the foreground thread, and that really, we haven't seen any errors due to this, even though the player does get that terrible loading hitch. And so ultimately the way to fix this would be to imagine like you have a big scene tree in memory and you have the game tree. If you just added like one node at a time over the course of like 20 frames, you wouldn't end up with these loading hitches. And I think that's ultimately the right way to like progressively load a Godot scene, is to like bring it in one piece at a time. I think especially expensive is bringing in lighting and bringing in textures that haven't been loaded before, because Godot does freeze every time it has to compile a new shader, and every material that hasn't been loaded before is a shader. So that ends up causing like this very long freeze while Godot like on the fly compiles its GLSL. so anyways, in the foreground, we just do our whole load. And then in g.add stage, you can guess how this works probably, because it's largely the same as how loading menus worked, and we just looked at that, but it's going to add the stage to a list of known stages. It adds it to the game root, and the callback, right, because at the beginning of all this, we said the doorway wants to know when the loading is completed, so we want this callback to be called. So finally, global's been given the callback. If the callback is still valid, it's going to be called. The reason it might not be valid is that the doorway could have been destroyed while the load was happening, in which case there is, like, this function has gone away. There is no callback you could... Well, I mean, the function is still there, but, like, the object the function is attached to has been destroyed. And so the calling this callback would cause undefined behavior and throw errors. And so we just check if the object still exists, and if so, we do what we need to do and call the callback. Cool. So in doorway, when we finally get that callback, we're going to have to do a little bit of work. We're going to move. So imagine you have two stages and they load. They don't really overlap correctly at all. Like, they're both going to be in two random places in space based on where they were in their scene file. And so we want to get those two doors that are supposed to match up perfectly. So what we do is we take the... Oh boy. There's two lines here. The first line positions the first line rotates the new stage, so its doors lines up perfectly with the old stage's door. The second line moves the new stage so the doors are perfectly flush to each other. And so that involved some... I've not done very much matrix math before, but the idea is that if you multiply by an inverse, you're essentially subtracting a matrices. So we take the target door and we subtract our current door's rotation from it. So if you imagine our door is rotated this way, target door is rotated this way, subtract them, we get an angle between them of this much. Now we're going to take that angle and we're going to subtract it from the rotation of the parent stage. So we invert the matrix that encodes this angle, we multiply the parent stage by it, now the parent stage gets rotated that much, which, if you think about it, that means new door is a child of parent stage. It gets rotated by that much because the whole parent stage rotated. So now both doors are perfectly lined up with each other. The only problem is one's over here, because when we rotated it went like that. So now we just take the origins, and this is the simpler math. We get the difference between the two door positions, and we move the parent of this stage so the doors line up. And so now our doors are, like, flush to each other. The other horrible things here, each stage has a door, right? You saw in the plateau there's a door, and in the throne room there's a door, and if they perfectly line up with each other, they're going to do some gross Z fighting and, like, flash a bunch, and when you press E, you're going to trigger both of them. And so what we actually do is, this variable in doorway that tracks what its current door is, we overwrite it with the other door. So on load, we find our current door, like, we go through it, like I said, we loop through each child, find one that extends the door class, and that's our current door. But when we load a new stage, we tell the current door for the new stage to just go away. We've already got one, thanks. And we overwrite it with our door. So both stages now exist in parallel, and they both point to a single shared door. Yeah, so that's kind of how that works. And then if the player... Every frame we're checking has the player clicked on the door. So... I need to remember exactly how this works. So this is when we exit the volume. We want to confirm, we're checking every frame. Is the door closed? Is our stage currently loaded? Is the player only in our stage and not in the other stage? And is the player not currently in the trigger volume? And as long as all of those are true, we can unload the other stage and claim the door. So, like, the door, while we both have a reference to it as a variable, it actually exists in the scene tree only on one stage or the other. So we actually, when we unload one stage or the other, we have to move the door to be a part of the stage we're going to keep. Here we go. So the door can request to be opened itself. That's why I'm not seeing code for opening the door. It's because in process we're checking if the other stage is loaded, and the door is asked to be opened, we will tell the door to start open. And that means we now need to look at how the door is. So door.gd is one script, and simple door is another script. And the idea is that there were going to be many types of doors, right? Like, for thematic reasons, you want a bunch of different types of doors to fill up your game. So, but there's one platonic, like, parent class door that Doorway cares about. So Doorway's interface to whatever its child door is always through this door class. And the door class really only has this one property, state. And so the parent reads properties from state or writes to state, and they both like change to respect whatever state has been set to. So by default, state is closed, but the state can go into request open mode, which means we'd like to be open, but we are closed. It can go into opening mode, which means it's like the animation is playing, but it's not done. Or it can go into open mode, which means the animation is done. Or it can go into like closing mode, which means it's shutting. Note that like there is no request close because the player doesn't close the door. It closes automatically. So there's no need to like wait for them to press E to ask for it to be closed. We just request closed when we get far enough away. I believe the doorway requests the close actually, right? Nope, the door asks for it. So okay, so these are all these different states that a door needs to support. So then the simple door actually like implements those states. So how do we read this? Every frame we check if we're in the opening state, and we weren't just in the opening state. It means we should start playing an animation to open the door. If we're in the closing state and we weren't just in the closing state, we start playing an animation to close the door or like open it backward. But like the implementation of this could be different for every door, hypothetically, because every door could be like, I like spiral open, or like I like, I don't know, moving like a cool like pattern, whatever. Like the animation could be different, the events could be different, as long as the state is ultimately updated to be correct. And you can see that when the animation player is finished, it always does this anim done function is like called when it's done. And that's where we say, well, if the state, okay, this is a Python, this is an insane Pythonism. This is a ternary operator. So in like most programming languages, you do like var x equals 1 true question mark 1, otherwise 0, right? So that means if true, then 1, else 0. In Godot, you read it like backwards. So you read like opened if state equals true, else closed, which means this part comes first, if state equals opened, opening, then open, otherwise close. And so like the order, usually like if statement condition, then true branch, then false branch is super common. Godot does this like backwards where it says true branch, condition, false branch. I think they're just copying Python. It's very weird though, because say you had like super expensive computation, right? You don't want to do this unless this is true. This works correctly in Godot. If this is false, we just return this else branch. We only run this function if this was true, but it's brain hurting to read because you're like, okay, what happens first? First we do this computation, then we make a consideration, then we might like, every time I read this, I think Godot's about to do my expensive computation. But it's not. It's just what it is. This is Godot's ternary operator. So yeah, if we were opening, we go to opened. If we were closing, we go to closed. That's the whole point. And then the final thing to note about this is that we use this function, which you'll see all over the place once you start looking for it, g.isColliderPress. And that checks if it's a global function. You can call it every frame, and it checks a couple of things. But basically, it's did you click on an object in the 3D world? So you give it some object, and we're going to figure out, is the player looking at that object? If they're looking at that object and it's closer than some distance away, and the player's input is not currently frozen because, for instance, they've died, then we're going to return if they pressed it. Otherwise, we're going to return they didn't press it. There's some fun caveats here, such that, like, you can actually have an array of objects, which was important with doors because the simple door has two colliders. There's a left door and a right door. And so here in simple door, we actually pass, have you clicked on either the left door or the right door? As long as you clicked on one of them, then the state goes to requested open. So every frame we check, did the player click one of the doors? If so, we request that it be opened. Even if like it can't be opened yet, we can still ask. And it's on the doorway's job to figure out, yeah, we accept your request or no, we refuse. I think there's something else I want to say about this. Right. Global, this. There's a property here that doesn't... So there's this global g.player function. That does what you would think. It just finds the player. The player's tagged with a group, and so it's very easy to find. We just have to call this getSingleton, which is a utility I wrote that wraps getTree.getNodes in group by name. So a lot of nodes in Godot can be... Any node can be tagged with a group. So this... Remember how we had like the inspector, then we had nodes, then we have this groups thing. You can tag a node into a group, and those are just like, they're O of 1 lookups basically to find everything in that group. And then I find that I have a lot of groups that only have one member, so I have this getSingleton helper function that gets the 0th member of the group by default. Right? So if there's anyone in the group, then we return the item at index, typically 0. You can use it to return something else, but I don't think I've ever used this optional parameter that I gave myself, but I figured I would let myself have the option just in case. Oh, what did I just do? Okay, cool. So yeah, so all that said, we get the singleton for player, which is this helper function. We use this helper function player to get the player singleton. And then in is collider pressed, we can use the player, and we get this looking at property, which in the player script gets set every frame to whatever the player is currently looking at. So yeah, player has this looking at property. Every frame we compute what they're looking at. And yeah, that's just going to be a raycast from the location of the camera out 100 units, ignoring the bullet, colliding with things on certain layers. And then we get the result. We also annotate. The result of this is a dictionary, so we can just tack other properties onto it. And I find it really useful to know how far it is to the target. So I just tack on a quick, like, from the results position to the camera, how far is it? And store that on the result. Yeah. This is unused code. This must have been for debugging at some point. Doesn't do anything, obviously. Yeah. Anyways, I'm going to leave it there, but just because I don't want to commit new versions of this because the jam is over and I'm very done with it. Okay, so anyways, that's how you figure out what the player is looking at. There was some other helper here that I thought would be interesting. Oh yeah, in here, you'll notice we have this raycast. So like I said, there's a ton of little helpers in global for like, the way you do a like one-off, usually in Godot you have to like add a node to the tree to do a raycast, but there's this helper function if you do get world.get directed space state, get direct, the world space state has an intersect ray function, and so I just have this wrapper around that whole mess to make it a little bit easier to use. I also have this helper. Normally, Godot nodes that are collidable have a collision layer and a collision mask. Now, the way this works, every node in Godot can be on a like one or more layers. And whenever something wants to, like, say I'm a bullet, I'm moving through the bullet world, and I want to see, like, did I hit something? Well, the something is on a layer 1. If the bullet wants to hit it, it has to have the mask of layer 1. So the stationary object is on a layer. The moving object needs to have a mask to see if it touched that layer. So typically, you have everything on layer 0 and everything masked to layer 0, so everything can hit everything else. But we ended up putting, like, bullets go to layer 1 so that they can't hit each other, and then they mask to layer 0 so they can hit things on layer 0. But building these are actually just like an integer, right? Where like an integer is like 32 or 64 zeros in a row. And so we set bit like right? So you can see here bit 0, bit 1, bit 2. In that popover, it says collidables bit 2 value 4. So which bit is set in your integer, which bit is 1 or 0 defines this mask. And doing that math on the fly was a little bit annoying for me. So I built a helper function that will give an array of, say, like you want layers 1 and layers 3. The helper function takes that array. It makes, this is, 0, but it's really like 0, 0, 0, 32 of them. And it goes through each layer, and it applies this, like, we're by taking 2 to a power, 2 to the power of, like, 0, or 2 to the power of 1 is 1, because, like, 0 is 1, 1 is 2. And then, like, 2 to the power of 2 is going to bit shift it over 1. And so, like, we're bit shifting that 1 to the right position. And then we're adding that to whatever the overall mask is. And so if the overall mask is 0, for whatever reason, we want to return this. But otherwise, we return that, like, mask that we've built up of, like, 0, 0, 1, 0, 0, 0, 0, 1. Yeah. I'm just reading binary to you now. You're welcome. I hope you enjoyed Binary Hour with Alice Zinsky. Anyways, that's the mask bit, and that's kind of builds up to how the raycast worked. So that was our little diversion through, like, some of these helper functions. They're all here for some reason, mostly. And all that said, we can get back to the door. We can see, is collider pressed? If they were within 3 units of one of these, and that's what the player was looking at based on a raycast, then a press happened, and we can set state to request open. And then the doorway, like we saw, if they've requested open and the stage is loaded, then we go into the opening phase. And when we go to the opening phase, because we're both, like, acting on the same state tree, the simple door sees we're in the opening phase, it opens, we can pass through, blah, 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 blah. So how do we know to unload? Like you saw before, the unload check is happening in process, and we've got all these little things we're looking at. Is the door closed? Because if it's open, we can't unload. It needs to be closed. The stage, actually, our stage needs to be loaded. This isn't like a high bar to pass because... Oh, no, I'm sorry. The other stage needs to be loaded. So if the other stage isn't loaded, there's no need to destroy it because it doesn't exist to be destroyed. So if the other stage is loaded, if we are in only our side. So you'll have to imagine if two stages are loaded on each side of a door, they each have a separate doorway script. So there's very often 2 of these doorway scripts governing the same doorway. And so the way that I think about this, it's always a doorway script's job to destroy its opposite. So if I'm on the right side of a door and I just wander off, the doorway script for the right side will destroy everything on the left. And if I'm on the left side and I wander off, the doorway script for the left will destroy everything on the right. And so we need to know, are we on only our side? So if we're on the right side and not on the left side, we can destroy everything on the left. So this is what this in our stage and not theirs check is doing. We want to know that the other stage is actually loaded. We get all the current stages the player is in. And then if we are in our stage and not the other stage, by doing just a simple has operation, this returns a string. Every stage is required to have a volume. So this is in the group stage volume, and it's a simple, like, collection of collision shapes that, see all these, like, big blue wireframes around the edges of the stage? That's cumulatively our stage volume. If the player goes out of the stage volume for more than 5 seconds, they get game over because they've, like, fallen off the level. But we also use this to check if we're in a stage. So when I exit, so for instance, you can see this blue cage is the doorway's like, are you vaguely close proximity sensor? And so if we are out of the proximity sensor, so like we're here and we're only in this stage volume, or we're not in the stage volume over here, then it's safe to unload everything over here. So we have this helper function global for get all of the current stages we're in, which is a wrap around get all the current volumes we're in. So we get all of the stage volumes. we check all of the bodies that are overlapping it, and if the player is one of those bodies, then we add the stage volume to the list of volumes. Now we can go through each volume. Each volume is only childed to a single stage, so we can go through each volume, get the node name for the volume, which means walk up the node hierarchy until we find game, and then whatever the immediate child of game was that we walked through is our stage volume. And so like now we've got stage volume. We walk up the tree, get parent. We recurse if we need to, but if the parent was the game root, then we get whichever our stage was. Great. And that's kind of how we know if we're in one stage or the other, and if we're only in our stage and not their stage, and we've exited the trigger volume, then we can unload. And so what does exiting the trigger volume actually do? Exiting the trigger volume closes the door. So if you actually exit the trigger volume, we find our door, and we tell it to start closing, right? And so we don't actually unload until we've gone from closing to close. So when we exit the volume, closing starts. The simple door sees we're closing, it does that animation. Once it's done, we're going to be closed, and so the process is going to like notice that and unload the stage on the other side. Cool. So that's how stage loading works. I think it's time to move on to another topic. So I think the thing to talk about is either we can talk about the player or we can talk about entities. I think I'll talk about entities. I'm going to try to go quickly through entities because it's going to be both like long and maybe not deeply rewarding. So under this entities folder, I'm going to breathe for a moment and drink some water. You should too. Remember to stay hydrated. I don't watch a lot of Twitch, but I know you're supposed to tell people to stay hydrated. And I also know this is probably going to be a YouTube video, so that's irrelevant. Don't stay hydrated. YouTube viewers don't drink water, maybe. I don't know. Internet's a scary place. Maybe everyone stays hydrated. Maybe that's a universal truth. Okay. Or maybe there's some social media network where they don't hydrate, but all the other social media networks, they do hydrate? Like the dry zone? Anyways. So I mentioned a little while ago that all of the like stuff in a level goes into the entities folder. So we'll talk about everything in here except for enemies for now. So let's just look at like how boost mushrooms work. They're the first one. They're kind of cute. It's a scene like all the other scenes. It's a collection of these little mushroom animated sprites. And well, I'm going to go on a little tangent first. See how this frame is an Aseprite file? That's not something Godot can natively do. Normally these have to be a sprite frames type. And the reason you can put an Aseprite file in here is because of that plugin I have installed, the add-on Aseprite Wizard. And that lets you just drag an Aseprite file in here. I don't really like it ultimately because getting Aseprite Wizard to work on two different developers' computers was kind of a pain. And worse, you need to have Aseprite installed to use Aseprite Wizard. So at first we only had Aseprite, only Mike had bought Aseprite, and then me and Tyler realized we needed it just to build the game because we were using Aseprite Wizard. And so we ended up like buying $60 worth of Aseprite when it really wasn't our intention. And so all Mike had to do is like hit export on an Aseprite file and like export a sprite sheet for us, which I know he wouldn't have had a problem doing. We just thought, hey, let's use like the plugins and like use the Godot ecosystem to its fullest. I don't think it was worth it. I think the complexity of needing to have Aseprite installed and finding it on your path and like configuring the wizard correctly was greater than the complexity of just hitting like export sprite sheet would have been. Nonetheless, like it is kind of nice once it's working that you can just drag an Aseprite file onto a sprite, onto wherever you need sprite frames. And so these sprite frames, actually one more thing about that. The Aseprite Wizard can only be used where you need a sprite frame. So if you need just a like a single frame somewhere, oftentimes sprite frames aren't supported everywhere an image can be placed in Godot. So I still had to open up Aseprite and export a bunch of still images if I didn't want like sprite frames, because I needed PNGs to use like in the UI and stuff. So like it was just not worth the hassle of using Aseprite Wizard. Is my review. If it, I think Aseprite Wizard would become worthwhile from my perspective if it supported exporting. If you didn't have Aseprite installed on your system and it was all pre-bundled with Aseprite Wizard, I think it would be worth it. But currently it's just a thin wrap around the Aseprite command line arguments, so not really worth your trouble probably. Anyways, this particular animation, okay, diversions aside, we're getting back into how the boost mushroom works, which is this like volume that pushes the player up. Has some cool particle effects, blah blah. So it's just a little animation I drew of like a mushroom slowly bursting open and releasing these gross fumes. So there's a bunch of mushrooms. There's also this surface below the mushrooms that like they're growing on. There's this, how does this work? There's a small collision area in the middle that you can shoot to trigger it. And there's a big column that goes way up above the mushrooms that is like your jump column. That's the thing that you actually like. If you're inside of it, it boosts you upwards when the mushrooms are active. Then there's a timer, and there's these particles that we emit. And so the particles are a pain to make, but they're also not such a pain to make. So I can turn them off, and they'll slowly fade out. Turn them on, they fade in. Particles generally have a... You make a particle node. You set up some like general properties, like how long should they live for, how explosive should they be? So like, should they all emit evenly over the course of a frame, or should they emit in a big burst and then 6 seconds later emit in another big burst? There's a big burst. There's a big burst, yeah. But for this, like, obviously the correct thing was to have it just slowly fade in over time. Then you have to tell it what, like, the little particles it's going to draw are. So in this case, I just have a point mesh, which is like the 2D point, and those are kind of frustrating to set up because you tell it I want a point mesh, and then you have to attach a material. You have to tell the material in like a resource flag to use the point size and actually like respect the fact that you have point meshes. And there's some other parameter I had to set, the point size, and say it should be 4. So like, and then I had to tell it was unshaded because it was really hard to like see these if there was no lighting on them, and like they just wanted to look like kind of sparkly. And so like sparkly things tend to look fine just unshaded because they're supposed to be glowy. I don't know, at least for a pixel art game like this, it's fine. Anyways, so to make those particles, you ended up needing this like point mesh with a spatial material on it, and the spatial material needs to have the right flag set to display particles. And then the actual particle, like half of the configuration for the particle is on the particle itself, like the lifetime and the explosiveness. Then half is on this particle material. And I believe the difference is that these are all like CPU side parameters, and the particle material is actually going to be ultimately compiled as a GLSL script and like compiled out to like machine code to be run on the GPU and sent to the GPU. So all this stuff in particle material ultimately goes to the GPU. Stuff like color, acceleration, velocity. And so by tweaking these, like the initial direction, the initial velocity, the color randomness, I got this effect of like, it's mostly brown, but sometimes it's yellow, sometimes it's like gray. And I got it to go up, and like it kind of releases and like slowly dies off over time. There's a little bit of it spreads out, so like it starts small and gets a little bit bigger. But all in all, as long as you're a decent distance away, it looks fine. Oh, you might have noticed the particles get bigger as I zoom out. That's because a point mesh's size like is constant. It's that 4 pixels is 4 pixels in screen space. So these dots are always the same size relative to your monitor. They just look big relative to the 3D world because everything else in the 3D world got shrunk down as the camera pulled back. So it's like not a good effect if you expect the player to be far away, but it's a really cheap way to do the effect if like maximum distance is like here, which is about as far as you can get away in the levels where this is used. All right, so how does the mushroom actually work? It's pretty simple. We just check every frame. No. When a body enters, and if the body is a slime ball or a slime puddle, then we go into the opening state. We start emitting particles, we wait for the opening to complete, and then once the animation is all done and completed, we can start a timer to know when to close. The timer lasts for 10 seconds. Cool. Oh, and we're doing this thing yield. I'm going to do this a lot, so I'll mention it quickly. This means Godot should just wait for a signal to occur before continuing. So all these things, these signals, things like animation finished, frame changed, you can just wait for them to happen. So, like, if I want to say, like, $mushroom1 dot. So I could yield. So this is going to tell Godot, run this function up to here, and then, like, throw it on the back burner and let other code run. When this animation finished signal is emitted, then pull this back onto, like, the foreground thread and actually continue onto line 40, 41, 42, etc. And so we can use yield to, like, orchestrate a sequence that we know will happen over time. So, like, this doesn't happen in a single frame. The animation has to slowly play, the particles need to be allowed to start emitting, but we want to write it as though it was, like, one function. And so this says, okay, it's not open, we're gonna start opening. Once we're done opening, we'll continue. So, like, do this first half, throw it on the back burner, then do the second half once it's done. There's this special signal, though, called completed, which comes from if you have a function that yields and you call it, it returns an object with a completed signal. And that completed signal will be called when the inner yielding thing is done. So we call this open function. It's going to loop through every mushroom, advance their frame, wait like 0.2 seconds, play the next frame, wait 0.2, play the next frame, wait 0.2. And once all of that is done, this whole function, the thing it returned when you yielded, will fire the completed signal, and this function can then continue. So it's just a nice way to stretch your code out over time. The thing it's very bad for, though, is highly interruptible code. So if you're yielding on something, the only way you get woken back up is when that something is completed. What you really want to say is, like, when I'm completed, like, or yield, like, g.player died. And, like, if the player dies, like, maybe we want to say, like, just give, like, we wait till opening is done, but if the player dies before opening is done, like, we don't care, or something like that. Like, it would be nice if there was a way to say, wait for one or the other, because that happens a lot, and is the root of that bug we saw where an enemy will continue shooting after they die. That's because the shooting logic is all done, it's a single function with yields, and it's not very easy to make that yielding logic stop mid-yield. There's probably a way to do it, but I didn't really find it, and it's, like, a source of a couple of, like, visual annoyances that border on bugs in this game. Anyways, when the slime ball hits the mushroom, it opens and starts a timer. When the timer is done, it closes and says it's completed. And then everything else is in physics process, right? So if the player has entered that boost column, that big column here that, like, goes all the way up, if the player is in that area, we are going to use that raycast function we talked about and check if they can actually see the, like, collider below them. So if they can raycast down from themselves and see this platform, that means that we're going to apply a boost to them. So, like, if you imagine, like, there's, like, a big cube or something here blocking the boost column, we don't want them to be able to be on top of a platform and be boosted anyways. They need to have a clear line of sight down to the ground in order for the boost to be applied. Or, like, conversely, you could think of it like boost actually has to be able to raycast up and hit the player to push them. And if it can't hit the player, it can't push them. So we check, is the player overlapped? Can the player see the collider? And if so, we get the distance to the player, and we get the velocity to apply because of that distance. So, like, if the player's right at the bottom, they get a big push. But if they're way up at the top, they get just a little push. And that's just based on the length of that raycast that we just did. And so we figure out that like velocity to apply, and we can note to ourselves that like we are in fact like boosting the player up. And then there's a bit of logic here to apply that velocity. Like if they're on the ground, there's some friction applied. If they're not, like there's some slowing over time, so that like if they move out of the stream, it'll slowly unapply. And then we just move and slide them. In theory, g.player is already calling move and slide, so we're calling move and slide twice per frame, which could be the source of bugs I don't understand. There's like a warning in the documentation that like you probably shouldn't do this, but it worked fine for us, and it meant that I didn't have to like, I was able to write this in like an hour or so because I didn't have to open up the player class and figure out how to integrate like bonus physics forces into their physics. So this was just a cheap way to add that effect, and it worked pretty well for us. All right, so that's the boost one. What else is worth looking at in here? Buttons get reused a few times, but they're not actually that interesting. They use the same is collider press logic that we talked about before, where there's like the raycast from the player and a distance check on that raycast. Maybe interesting. It uses, again, this text 3D that we've seen a few times. You can only click the collider for the button is this like page around the top that's just a little bigger than the button. So if the player's looking at it, but they're a little bit off, they can still click. There's much to say about it properly. The way you consume the button is that you call is pressed every frame to check if it's been pressed. In theory, that could be a signal, but in practice, this was faster and easier to write, and it's a game jam. So next up, chains are, I think, very interesting. So watch this. I have a chain node. It's got a script. That script exposes this length property, and I think this is cool as all get out, and one of my favorite things about Godot now. If you set the length property here to like 10, you get 10 links of chain. And so like the links are added in the editor programmatically, but I think the default is 0. So I'm going to leave it as 0. But if you look, by saying tool, it means this script runs in the editor. And I export this length property, and I make it a setter. And so whenever you set the length via the editor, setget is telling it should call this setLength function. So this function is called, and I can do whatever I want. If you increment the length, it runs in the editor. I clear out all the current children, and I get all these chain sprite instances. So that's just this like single chain link here. That's one link of the chain. Also, I drew this and I'm very proud of it. I think it came out super good. Okay, but we go through and we add each of the chain links to the parent chain, and we offset it by its. So we just add a link. We add the next link below it. We add the next link below it. Cool. The thing that's neat, though, is that it's happening in the editor, which I just think is awesome. And I think the fact that you can use the combination of an export plus a setget to set a variable in the editor and actually run code without having to like write a whole plugin is super nifty and made it easy to like visually build certain assets like that. And I will probably use that trick in the future. In fact, I did to build the gate. So if you look at the gate, it uses the exact same pattern of like, this is a 5x5 gate. Whatever size you want, you plug it in there, and the gate will grow to that size. You can change the texture in theory. Yeah, but I just thought that was like a neat effect. So I used it a few times. It just quite happy with it. There is a mystery, though, that I want to mention quickly, because if someone knows this, I'd like you to tell me what the hell is going on. See how this chain here has no children? If I increment this to 5, you can see 5 children were just added. And in the script, we called add child. But over here, no children were added. And I don't know what's going on. Because I don't think Godot, like, I don't know why those children aren't appearing here. Because they are appearing here. It's like maybe there's a separate setup of all of these. Maybe everything you see in the viewport is one scene tree, and everything you see in the scene tab is a different scene tree. But the fact that they're not like completely synchronized is alarming to me. I would have thought that like this, and this are all kept totally in sync, but they're clearly not, because in the viewport you can add and remove nodes, and here they never get updated. So like maybe it's a bug and it's just supposed to, it doesn't know to check and see if things have been added because it doesn't know that like a plugin is loaded. But I think there's two instances of the scene tree somehow. Anyways, I just wanted to mention that because I think it's kind of interesting. So that's the chains. There's this crystal dome that never got used, but it works like the goo gun in Prey. Actually, I'm going to show you how that works quickly because I think it's cool, but I'm not going to talk through the code because it's not actually in the game. I just think it's neat, and I want to show it to the world. I don't remember what it's called. Crystal dome? No? Alright, we can check. It's in data tables, right? Everything tabular is in data tables. So it's crystal, walk, and dome. These are two abilities that were implemented but never actually made it into the game. The way this worked, you would hold Control and scroll to scroll through these abilities, and you'd use right-click to fire them. So there's a dome, and you could actually like platform on it. And if you fired it close to you, it would like kind of push you back a little. Right, I need to kill the enemies first. Oh yeah, so you got this dome. You could like kind of use it to like do silly things. We were really curious if you could use it to like knock yourself out of the level, and I bet you could, but it wasn't exactly. You would need to find like a corner you could back yourself into to pop yourself out. But yeah, it was this like goo gun sort of dome ability. And it had a sibling ability, which was Crystal Walk, which would, when you hold down the right mouse button, it would make the dome transparent. You could walk right through it. So you could like use these together to like block off a hallway from enemies, and then like walk into the dome, and then like I think your bullets would go through it, but their bullets wouldn't. So you could use it as like a shield. So the idea was that like early in the game you would unlock the dome ability, and then later in the game you would unlock Crystal Walk, and like your old ability would become like new again because you had this way to like use it in combination with something. Anyways, I'm a little sad this didn't make it into the game because I just think the implementation is cool of like it goes transparent, you fall through it, and then it stays transparent until you leave. Like there's a lot of little like logic there that I was like pleased that I got right. Yeah. So that's this cool little pew pew pew. Sad I never made it in. Also, notice how the geodesic dome is like growing in like steps? I kind of did that on purpose because I thought it looked nice and organic. The actual physics collider is growing smoothly. So like it pushes you away from it actually very smoothly, but visually, because of the like jumpiness of how it grows, because it's supposed to look like a crystal kind of like growing in juts, you like think it's pushing you away not very smoothly. But if I shoot behind me and turn around, like I just slide pretty cleanly. Anyways, that's the crystal gun. Sad it never made it into the game. But proud to have implemented it. And it had those little icons at the bottom left too. Like there was a lot going on. All right, cool. That's the crystal gun. So there's the crystal dome, which we see here, which knows how to grow. I'm not going to break down how we do this, but like it hits a wall, it grows. Then there's the crystal walk, which is, I guess, not in here at all. It's just in the abilities section somewhere else. All right, cool. There's this damage burst, which is just it's a particle effect that gets smacked on an enemy when they die, when they get hit, and that's that burst of damage. These dialogue triggers got used a lot. It's just a collider with nothing in it. The script really only exposes this export variable message. So these got used, like if you walked into an invisible volume and some text appeared, this is how that was done. You just put this volume somewhere, scaled it in the scene where you needed it, and then like set the message to whatever you want. So here, set the message, and each instance of it obviously has a different message set, because all these variables, right, are stored in the tscene file. So when you make an instance of this in the tscene file, the message you save there is different from the message in this the scene it came from originally. And then really all this does is when a player on body entered, if the player entered it, they haven't seen the message we're holding before. So this is maybe the first time we're seeing, hey, we're accessing game state, we're accessing the stats, we're accessing that lore list. So if the message hasn't been shown, we show it and we save it and we like save it off to that list of lore entries. And so we can see in this function, for instance, nope, we're not going to go in there yet. I'll talk about how dialogue works later. Yeah, but this is a trigger for dialogue. We've got this door shield. This was very like shoddily implemented and quite buggy. But this is, if you remember all those semi-transparent green volumes in front of doors, these are literally just a separate object which is childed to the door. And it's that object's job to, you place it, you set it to whatever like width you want, and then this thing checks if it's been shot. If it's been shot, meaning take damage was called, it will go transparent if the shot was from whatever damage type it expects. So this expects green damage and is colored green. But in theory, it could be like, it needs to be hit with the scanner gun to open, or it needs to be hit with whatever. So whatever damage type, it just checks if the damage type matched, in which case it'll transition open. It would have been nice to make these part of a door, but I implemented these like literally a day or two before the game jam was done, and so this was just the fastest way to do it. They do, though, get... They auto-open when the door behind them opens. So the shield's only on, like, one side of the door. So you have a door, and there's, two sides to the door. The shield's only on one side. But when the other side opens, it does take down the shield, so you don't have to, like, shoot it to pass through. Anyways. The enemy die is another particle effect, which is just a different particle effect that I play when the enemy has been defeated, and I just play that, and when it's done, the enemy is destroyed. This is just that platform cube. The only thing to say about this, really, is that there's a dialogue tag on it. So this is a node, you add it. This is a tscene we have, and the tscene works a lot like that dialogue trigger, but in this case, it's not being placed just on the ground somewhere randomly. It's being placed as a child of some existing node. All right, so how does that work? You tag this node, and that means it's going to go find its parent node that is collidable, mark the parent node with a scannable tag. So we tag our parent collider. That means we add the scannable tag to it. And that means that when something scans us later, it's going to know, oh, that was scannable. I'll grab the child dialog tag and see what its tag is. So once again, we're using that pattern of like, you tag it and then you put in some text for like whatever it's supposed to be. This was called a sarcophagus, I suppose. And that would bring up the sarcophagus text from data tables sarcophagus. Yeah, this little bit of dialogue about Talon 4. All right, that's the tags. The only interesting thing about the tags is in certain scenes, like the save point in particular, this thing you're tagging is not collidable. Well, nope, that's the wrong example. Where did this happen? There's something you can tag. The vending machine? Here we go. Okay. So when you import a gltf file, meaning the file you export from Blender, it automatically creates a node scene, like a node for you, where if you look, this is just a like empty spatial. This is the actual mesh with its texture. It automatically created a static collider because of some settings I set in Blender when I exported. And that collider is actually the thing that like the player can click on. But this whole tree is auto-generated. So if I ever re-import the mesh, this whole thing gets rebuilt from scratch. So I can't just add a like dialog tag to this collider. So what I do instead is add it to the vending machine like instance. And this script is smart enough to say, get parent. Is my parent collidable? Meaning, is this a physics body or a CSG shape? Okay, don't. CSG shapes and physics bodies follow totally different inheritance trees, but they're still collidable. So whatever. Okay, they are. And so we check, is our parent collidable? And if they are, we add the tag. But if our parent wasn't collidable, we check all of our parents' children, see if any of them are collidable. And we just do that recursively until we find a child that was collidable, right? So here we have the tag. Look at our parent. They're not collidable. But we're going to go through all of their children and eventually find recursively this child is collidable. So the tag puts the puts this into the group scannable, and then the tag actually moves itself. If you see this, we get our parent and we remove ourselves from our parent, and then we add ourselves to whatever the target was. So 99% of the time, that means we just stay attached to what we were attached to. But in this case, we end up attached as a child of static. Gotcha about it. For a while, this was a tool script. I don't remember why now, but I had this marked as tool, which means it runs in the edit. That's like cool. Kind of doesn't matter. The problem is if you reparent yourself, so you take, so this dialog tag saw, oh, I'm supposed to be childed to this node, so it moved itself, and then this gltf, right? So it removed itself from here, obviously, and it moved itself over here, and so it wasn't here anymore. And then the gltf got re-imported, and so it wasn't here either, and so that's just an interesting case of making something a tool that had like genuinely like very bad consequences because it was moving my node and then deleting my node. Yeah. That was scary. All right. So that's kind of how the dialog tag works. And then it's on the scanning gun is actually the thing that like scans. And so this is all just the nouns, right? This is a noun of you are tagged with this. And then all the verbs of like actually show dialogue is all in the scan gun. So yeah, that's the, where were we? Door shield, platform. This is a cool script that maybe I'll explain this as a bonus, but I'm not going to talk about it. It's the script that though, so all of the art in this game is like a flat asset that always billboards to face you. But if you get around behind something, it switches and shows like the back of the enemy. So like the billboard always faces you, but what the billboard shows will change if you're behind versus if you're in front. And this is the logic that says, give me a list of different like sprites I should show based on angle, and I'll automatically like divide up the area around the entity and change the sprite for you dynamically. So anything could. This was just the class that did that like division for you, and it's a little bit, the math was kind of wonky, but eventually it worked. And so if you ever need that sort of logic, it is in here in facing sprite. 4-color source never got used. The original intent for the first gun you get, the like just generic green damage gun, was that it would change color. So you'd shoot something blue and it would become the blue gun. You'd shoot something red and it would become the red gun. There would be some puzzles that used that somehow. But that never came to fruition. So this is like the something red, right? This is a particle emitter that is, it's green, but you can change its color to like blue, and then it should, in theory, that would start emitting blue. But it never got used, so it's not really that important to talk about. Gates, we talked about for a moment that you can change their size. The other thing they do, though, is they have a prescriptive structure. So they expect to have a child node named open button and a child node named open target. So if we look at like the Hive level, let's look at my favorite gate. I don't know why this is my favorite, it just is. We have this Hive gate here, and it has that open button, This is the button that's going to cause the gate to open. It's got an open target. That's just an empty spatial that says this is where the gate should go to when it's open. And it needs to have both of these things in order to behave correctly. So whenever you like add a gate to a level somewhere, you're going to set its size. So like set the number of links you want, like 10 or 5 or whatever. And you're going to add these two open button child and open target in order to tell it where to open to and what button is in charge of opening it. This again suffers from that problem I was mentioning of child in nodes moving with their parent. If I want to move the gate over, it moves the button, which is really unfortunate because it's really visually nice to just make a button a child of a gate, but it's logically bad to make a button a child of a spatial, right? Because I don't want them to move together, but I do want them to like act together logically. So like conflating this tree on the left with a like physical layout is a source of frustration again. Anyways, let's look at how the gate actually worked for just a second. I mean, there's not much to it. If you clicked the button, so should be a process function here. If open button is pressed, so this is just going to, I believe this looks every frame, as bad as that is, figures out which of our children is the open button, checks if it was pressed. This is that, we saw this function already in button. It's checking if you're 3 away, and like if you pressed E and you were allowed to press E and all that. And so if every frame, if the open button was pressed, then we just open the gate. And that means that we play the animation of the gate rising to the level of the open target, right? So you remember we have this open underscore target, which we found at some point we figured out what that was. Open target, go through each child, find the position of the one named open target. So then when we animate open. Also, I have a tween helper. So in the same way that I have that raycast helper, this is a tween helper that basically takes care of some of the minutiae of dealing with a tween. So all I have to do is say, do the tween and yield for completed. And then we just wait till that's done. Okay. Then what? There's one other thing to say here. In the pit stage, there's 1, 2, 3, 4, 5 gates. They open in phases. These two open, then these two open, then this one opens. If you get these first two to open and leave the room and come back, they're going to be closed again. Typically, when a gate opens, it automatically saves whether or not it's open or closed. But in this stage, I needed to only save if they're open or closed once you've finally gotten all the waves cleared and opened this last gate. And so I added this flag to a gate called autosave. They won't save they won't like persist that they're open to the game state unless autosave is true. Otherwise, you have to explicitly call save state. And so you'll see in the pits script, once we get to this like success phase where, I mean, the pit has functions for when it starts up, then for starting wave 2, then for starting wave 3, and then finally we're done. And it's only when we're done that we then say save state on all those doors. And like lock in your win, basically. So yeah, the gate can behave in either way. In most cases, though, I didn't want to have to call save state explicitly, so I just had this flag for autosave, because most of the time I just want to autosave it. But in levels that had like that longer sequence of gates, it was nice to have the ability to lock it in only like once victory was achieved. Okay, so that's gates. Yeah, these are all kind of like, I think they're hopefully starting to feel pretty perfunctory if they weren't initially. Health blob. This is what we call programmer art. It's just supposed to be a little floating orb of health. If the player walks into it, we call their take health function and give them health blob amount of health. I'll talk about how players heal when I talk about everything else about the player. This is the water. Wow, there's a script on that. That's wild. I didn't realize I had a script on that. Anyways, this is just a semi-transparent septagon nonagon of water that I use in a few different places, including in the fountain in the beginning, but also like wherever there's a puddle, it's really just this same piece of water scaled. Save points are startlingly logic light. There's a dialogue tag on them so that you can scan them. There's a light and a audio player that play when you like actually save. There's this text that tells you E to save, and the actual script is really simple. Oh, that's really smart. Wow, I'm so clever. So, okay, this is collider pressed function. I moved it into an input function. So whenever the player presses a button, we can check, did the player just press the button on the actual like node that we care about. So in this case, we care if they pressed E while looking at the static body of the save point. If they did, we can save, we can take a full heal, and then we can show the dialogue. This was like a racy. This prevented, sometimes the dialogue wouldn't show up and just waiting at 0.1 seconds causes it to show up every time. I don't know why, but I didn't have time to fix it correctly, so I just threw in a wait. Save points do need to have unique IDs per stage. If I only have one save point per stage, I might just call it must be unique per stage and not bother to edit this. But if there's 2 save points in a stage, we need to know which one to reload the player to. So just like we've been doing with like gates and doors and everything, we export a string and you have to give it an actual name. Yeah. That's how the save point works. I'll talk about the slime stuff when I actually talk about the weapons. This is just a stun effect on the enemy. I'll talk about that when I talk about enemies. Vending machine deals with sequencing of the layout's very similar to the save point, right? It's a facial. This is the node that we imported from Godot. This is a dialogue tag on it. These are both, depending on if it's out of inventory or still has inventory, it'll show one of these two meshes. And then this is all just show the different purchasable items in order. This is the logic. If it's available to buy, we'll go down this path and check if they tried to like clicked E to buy. If they did, we figure out what they bought and put it in their inventory. If it wasn't available to buy, either it's because there are no more guns, or it's because they didn't have enough artifacts. So we show the right like text here for if there are no more artifacts, text here for if there are no more guns at all, or if there's not enough artifacts. And then these are the oscillations. So you notice the next purchasable gun icon sort of bobs up and down in front of the vending machine, and that's just these two little sine functions. Right, sine goes from 1 to -1, and so I feed in the overall elapsed game time into it, which we saw game time as being, it's not a Godot, it's not available in Godot, but we set it in main.gd and make it available in the global. So g.gametime should be like the elapsed time since the game started. Feed that into sine, it'll wrap it to return a value between 1 and -1, and you just get this nice bobbing value. You can scale the game time to make it bob faster and slower. You can scale the overall output of the sine function to make it bob like, from 1 to -1 is very high, so we want 0.002 to get nice little oscillations. Cool. And then we have weapon pedestals. These are like largely similar logic to the vending machine, where we say, depending on which type of item it was, it goes into the player's inventory in some way. I guess this is like an obvious case of dispatchable code, right? Where like the item could have a like give to player function, and on the item we could move all this logic to the item, and then each item would have a small script with like on pickup do thing. But not all of these items had their own scripts. I didn't really feel like making separate like scripts for each of these like 2-line actions. So I don't. So yeah, that's kind of all the entities. Actions, these were that unimplemented like crystal walk. So like that become passable stuff. This is enemy behavior. Bullets we'll talk about when we talk about guns. Doors. This is doorways, which we talked about. How we load different sections of levels. Elevators. Okay, before I do elevators, that'll be the last piece of entities. We'll talk about filler. So all these things are just like random 3D models that I made or like made in Godot or Blender to fill out levels. So like just tiny little things that like make the game feel more complete. The trees are in here, the vase is in here. And they don't really have scripts on them, they're just filler. I will say one thing though about Big Statue. This is made with Godot's CSG shapes, which stands for, I think, constructive shape geometry, something like that. The idea is that you can make a bunch of. It's for rapid prototyping Godot. So, like here, you just make a CSG sphere. You set a radius for the sphere, and that's like your collider, and or that's your like object, like your mesh, and then you can say there's a box you can check on the parent here on the CSG combiner that says used for collision. You check it, and now players can just collide with it, and it's awesome. Only this is really buggy. On my computer, it worked fine. When Tyler loaded the game, even though the collision box was checked, collisions never happened, so any CSG shape he could walk straight through on Windows. So Linux works, Windows doesn't. Something happened. I was setting use collision programmatically in a tool script, and I think it like got Godot confused for him permanently. And so I ended up like at the last minute we couldn't figure out what was wrong, and so I rebuilt the entire thing using colliders. So I ended up building it with CSG shapes and then wrapping it in a cage of colliders that are the exact same size as the CSG shapes, which was super annoying to like get this silly little angled cylinder to line up perfectly. And like I could have wrapped it in a big box, but it felt nice to be able to platform on this thing if you wanted to. It obviously doesn't look very good. Like ultimately the correct answer is just build the thing in Blender. Like it'll be faster to build, it'll look nicer, and you don't have to deal with CSG shapes breaking on you and you need to like cage them at the last minute. So I've learned my lesson on CSG shapes. I thought they were my friends, but they're not. Cool. So yeah, that's the fillers. Talking about elevators really quick. This is largely using logic you've seen before. So invisible, there's the elevator. I turn it on whenever the game starts. So I just have it invisible in the editor because there's no right place for the elevator until the game starts and it knows if it should be at the top or the bottom of the shaft. So I'd rather just like hide it and not have to see like an object in the wrong place. The elevator, similar to the gate, expects two children, and underscore underscore elevator button 1, underscore underscore elevator button 2. It enables and disables those buttons depending on if it's at the top or the bottom. And then when you press them, it goes to one or the other. The elevator has 3 collision zones. There's the bonk zone on the bottom, which like if it hits you in the head, this is what prevents it from like pushing you through the floor. It just completely stops if anything goes into its bonk zone, or if a player goes in. There's this tiny little trigger in the middle called the walk-on trigger, which is when the player walks into the elevator, they have to touch this in order to make it start moving. So they don't just like nip the edge and then it like moves and they fall off the back. Like they have to get to the middle before it goes. There's an on elevator volume, which is this like big volume above the top. If the player's in there and the elevator is moving, it automatically like moves the player by the elevator's movement. So that's probably in a process function, I would guess, although I don't totally remember where I put it. No. Move to top. Here we go. So if the player is on the elevator, meaning if it's inside this on elevator, then we just take the global transform and add our velocity to it. So like as the elevator moves, it just shoves the player along. And that little bit of teleporting, like it seems unintuitive, or like it seems like there should be something more elegant where like we apply a force to the player, but truth be told, by being completely brute force and just setting their position upward a little bit, it's almost as though the floor itself had moved under them, and it works really well. I never end up with players like glitching through the elevator, and just having this like volume above the elevator seems to like do the trick pretty nicely. It also works if the elevator is moving horizontally. Other food for thought about this. You'll recall the elevator used a underscore underscore button 1 underscore underscore elevator button 2. It also has an elevator target, which is where it's supposed to go to. So each of those buttons then needs a child, which is the target. So at the top, I can show this in action. Plateau, GLAT, that elevator. So yeah, you'll see we have the elevator here, which is the platform, but then it has a button childed to it, and it has another button child at the bottom, and each of those has a target. So at the top, this is where it's supposed to go to. At the bottom, this is where it's supposed to go to. I have a convenience function. So it turns out it's a pain to line up exactly, make sure this button lines up exactly on the XZ plane with this button, or like it's busy work because 90% of the time, all the elevator does is go up and down. So we only care about setting the Y position. So I have this setting on the elevator. So much open. I just need to find the elevator and then I'll show you. All right, so there's a setting here called only do Y or something like that. Export Y only. And that means the top elevator, like elevator target, the X, Y, and Z matters. But for the bottom one, only the Y axis matters. The other X and Z axes are copied from the top one. So like even if they don't quite line up right, as long as you've got it on the right level, the elevator will go up and down to the right place. The elevator also has a little bit of like slowing down, speeding up attached to it. So as it starts accelerating slow, it speeds up, and then it slows down again. And so you can kind of like, that's all script tweakable, right? The speed, it's speed when it's moving slowly, how fast it accelerates, decelerates. That's all about like making the player like, it starts slow, it goes through the huge part of the like elevator shaft very quickly, and then it gets to the bottom and slows down again. So like if you thought that was happening, you are correct. That was happening. All right, so that's the elevator, and I think that's all I have to say about entities. So what do we want to talk about next? I don't know how long this video's been going for, probably a while, but it seems like it's, I don't know, maybe this is interesting to people. We can talk quickly about how stages work, although there's not much left to say. So stages, you can organize them however you want. It's critical that they have a stage volume, and that's actually all that's left. There used to be requirements like they must have a navigation mesh, but that fell away, and now there's like no mandatory mesh. So really a stage is just something with a stage volume in the stages folder. There's a template though. So like as we built more and more stages, oh God, why is, that can't be in the template. Cool. So yeah, this was the template. So the things a stage can have, navigation mesh also doesn't need to be in the template anymore. It can have a default spawn point, marked default spawn. That's where the player will appear. And so every stage kind of needs that for debugging, basically. Like if we just want to say like, just start me up in stage like 3, even if there's no save point to spawn from, the game will spawn you at the default spawn point. Then the stage volume needs to have like a collision shape and the right tag, like we talked about. So it's tag stage volume. It needs to have a collision shape that defines like the bounds of the stage so the player can go out of bounds. That's kind of how stages work. What else did I want to address? We can do guns, we can do enemies, or we can do the player. Let's do the player first because they kind of inform how guns work. And the player's very, it's a lot of dense code, but it's also very concise. So like if you look, the player's just a kinetic body, which means a thing that can move and hit stuff, but doesn't obey physics. Or like we have to implement all of our own physics on it. And then it's got a body, feet. Tyler, so I should say, Tyler built the player, so I'm a little bit of a spectator when I talk about how this works. And then the player has a manager for the guns and a manager for their abilities, which kind of makes like sense that guns are intrinsically part of a character, I think. Okay, so the player script has a lot of variables governing player motion. So like, you know, the gravity, how fast they fall, but also like for a split second after you go off an edge, you fall slightly slower and you can still jump as like a grace period. Just after you go off the edge, you're still allowed to like get a jump off, and that Tyler called it coyote time. So there's a little bit of that in there. And there's just a lot of like fine tuning, how fast, how sensitive the mouse is, how fast you're allowed to move in air, how fast you decelerate in air, like if you're on the floor, just all this tracking, right? Like the first third of this script is tracking. We read what our abilities are from the game state, right? So whether you're allowed to dash and whether you're allowed to glide, those are like dash and glide aren't like layered on top somehow. They're just part of the overall player movement logic. And yeah, dash and glide are part of the overall player movement logic. And so it needs to know, should I allow dash and glide? Generally speaking, I don't know how best to talk through this because it's a lot. I'll mention the damage on the player first because it's kind of easier than the movement stuff. There's a take damage and a take health function. That gets passed a string. We look into the data tables to look up the damage type, and then we apply it accordingly. So if we take damage, we flash the screen red to show the player they were hurt. If we take healing, flash the screen green. We initially just subtract the damage from our health, but if our health went below 0, then we like loop around until all of, and consume a tank. So health goes up by 100. We consume a tank. If the health went above 0, then we're done. If the health is still below 0 and we've run out of tanks, then the player dies. Similarly with healing, you increment the health. If it's above 100, then we start doing that wraparound thing where your tanks fill up and your health goes down until all of your tanks are full, in which case we cut off your health at 100, because like all the rest of your health just goes in the garbage. If you heal by 500 and you're already at full health, the rest gets cut off and thrown away, and throwing it away happens here. Cool. So yeah, that's kind of how healing works. You can't heal if your stats aren't loaded, so it's sometimes possible for the player to be created before load finished, and so they just need to check and make sure stats are actually like available. Yeah, that's how healing works. Kill if out of bounds happens every frame. This is initialization logic. This is just kind of a hacky way to not have to... We can just call this function and not worry about ready. So the first time this function is called, this is going to be set to the game time. Every subsequent time, this block is completely ignored and we do this stuff instead. So if we're out of bounds, OOB start time is not going to be incremented. So after 5 seconds, we're going to die. But if we go inbounds, OOB start time will be incremented every frame. So that 5-second clock just keeps restarting. Anyway, cool. And die just means that we load the game over menu. I'll talk about menus in a sec. And then doing a flash means at setup, we have this screen flash object where this is really cheap, but it worked fine. We just add a rectangle the size of the screen, so like anchored at 0, 0. 0, 0 is top left to 1, 1 bottom right. And we set its color to be totally transparent, so 0 alpha. And then that's all. And then when we actually flash, we do a quick tween to go from like 0 alpha to 0.4 alpha, then back down to 0 alpha, right? Low to high, then high to low. And you pass in whatever color you want. So when we do flash here, we flash green. When we do flash here, we flash red. That probably doesn't belong in the player class, but it's the only place it's actually used, so it's kind of fine. All right. Cool. Player movement. I really can't speak to a lot of it, to be honest. Tyler wrote it. I kind of know enough to like insert myself into it, but you'll know as much as me just by reading the code, to tell the truth. I did add this no-clip code in here, so if you toggle no-clip using the J key and development mode is on, you'll go into no-clip and like, we're just checking if you're in no-clip mode, we do one code path. If you're not in no-clip code, we do the other. And then I also had this input free. So I ended up adding like a lot of gating to the player functions to like say, don't process under these situations, because I was like building the game except for player movement, right? And so I needed to say like, don't do player movement if like the players die, they're not allowed to move anymore. I would have this freeze input set. But otherwise, I didn't really do much with this class. Yeah, not much to say. Ask Tyler for a video about this part. The gun manager I wrote, though, or largely rewrote, refactored heavily, something like that. It gives you a couple of simple First of all, the gun manager is just, there's nothing visual about the gun manager. There's this, all of the, like, the current guns you have and the active gun are all tracked in game state. The gun manager is just like a driver of game state. So it reads from game state and writes to game state. And then there's a separate system called stats UI that is responsible for showing that on screen. Well, this is sort of wrong, because what it is responsible for is showing the gun like in the like kind of bottom middle part is what it shows. So like that little bar in the bottom, like bottom right here of active guns, that's the stats UI. But the big gun here in the middle, that's the taken care of by the gun manager. So it does a couple things, including I think it's responsible for scaling the guns if the screen size changes, but mostly what it's doing is checking if weapon 1, 2, 3, 4, or 5 was pressed. And as long as you'll recall, you hold control and press 1 through 5 to change actions, and you press 1 through 5 without holding control to change weapons. So it ensures that you're changing weapons. It plays the animations for a weapon moving in, so like animate one out, animate the next one in. And so it plays those animations. Once the animations are done, it like tells the gun it's ready to go, and it's responsible for tracking if the fire button was pressed and the player's input's not frozen and all that. We can emit it communicates with the guns in two ways. First, it emits signals, trigger pressed, trigger released. Second, it sets a variable, trigger down. So if you want to read from it every process frame, check trigger down. If you just want signals, you can listen for trigger pressed, trigger released. And the gun manager is kind of taking care of emitting those at the right time. You can kind of read through this. There's a bit of commenting even. I believe whatever the active gun is just a child of the gun manager, but let's confirm that. Child. Cool. So, okay, right. So there's this holster gun, which is put the old gun away, then draw gun, which is take the new gun out. And so when you draw the gun, we add as a child whatever gun we're drawing. And then all of our guns are... So I guess that's all I have to say about the player itself. They're typically a child of the stage there. No. The player gets spawned in global. And I believe they're a child of common. Yep, here we go. So this is where we instantiate. There's a spawn function. And, you know, this is the spawn at default. So you'll recall we had that default singleton in every stage. So there's a function to just respawn the player at the default. Otherwise, they spawn at whatever spawn point you pass in. And we have to make an instance of the player, and then it gets added to this common root, which is this idea that, like, game is going to be full of, like, stage stuff that, like, over time, they're going to have one stage load in, the previous stage load out, and that's going to cycle. Common is all the, like, 3D entities that persist between rooms, which really means basically only the player, but in theory, anything that persists between rooms could go in there. So yeah, you can heal. Right, when the player spawns, they heal. I'm now just reading code out loud to you, so that's bad. So let's move on to guns. And I'm just going to talk about the 3 guns that made into the game. There's the 4... I'm going to talk very little about the 4-color gun, because it's a little bit of a... All it does that's important is it shoots bad guys, and it drops the shield, in theory. But dropping the shield is easy, because it just has to call take damage on the shield, and shooting bad guys is also straightforward. So, if we look at how the gun works, it's ignoring all the set color stuff, because that was never used in the game. It does work, but it's not used. Every frame we check, we get the player's gun manager, check if the trigger is down, and if we've waited long enough for the fire delay. So we're only allowed to fire once every 0.18 seconds. So that's the, like, pew, 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 pew. That's 0.18 in between each shot. And so if the button has been held down for that long, trigger pressed is triggered. If the button is pressed, we connect to that trigger pressed event. Trigger pressed is also triggered. So if you click really fast, you can fire slightly faster than 0.18. Make of that what you will, I guess. Maybe someone could, like, bind that to scroll wheel and, like, scroll really fast or something. But I don't think it's super useful. Or, like, it's not... We didn't... Whatever. There could be some maximum click rate for clicking as well, I suppose. Anyways, every time you fire, we play this little sound effect. Again, like, if you see sound effect, you know that was added in the last, like, 24 hours. And, like, we just slap a sound effect node onto something, attach the sound file, and hit play. And, like, play it with code. And then we actually fire a bullet, and then the bullet, in this case, we need to know if the bullet hits something blue, we turn blue. If it hits something red, we turn red. So after we fire the bullet, we attach this onColorHit function to the bullet and have it call our onColorHit function. So that, like, the bullet travels through the world, it hits something, it feeds back to the gun what color it should become. And then this is called, and that's how we, like, change our color. And then there's a little animation to switch colors where, like, it would like suck in, sort of, like, and then the color would change. So we had to play that animation before we actually switched the color. Anyways. So the important thing is every gun extends this gun class. So there's a gun manager supervising the guns, and they treat them generically as, like, all guns are just an instance of gun. And then each of these guns extends gun. And gun has this helpful function called fire bullet, which is used to spawn a bullet at the tip of the gun and send it forward, right? So we go into gun, and fire bullet spawns a bullet at the middle of the world. We then position the bullet relative to the bullet origin. So every gun has to have this bullet origin. So where the bullets come from is this point, right? If I put it here, you're going to see our bullets launching from the wrong place. Right, so the bullet should now come from the top left. So the bullet origin is just totally a cheat to, like, give a point in 3D space that corresponds to where the gun is, like, in 2D space. So 2D gun, but it shoots into a 3D world, so we kind of need to know where to stick that. So we do a little ray projection from, like, the plane of the camera to that point a little bit ahead of the plane of the camera, and that's where we start the bullet at. Then we set the bullet to face whatever the player's looking at. This is where we're checking. If it's more than 3 units away, we turn to look at whatever the player's looking at. If it's less than 3 units away, we just go to a point projected forwards from the middle of the screen, 50 units. And so, yeah, that's this, like, project ray normal from the viewport rect divided by 2, which means the center of the screen. And then bullet has method. Right, so some bullets want to know when all of this initialization has been done, and if they have the method, we'll call that method on them. So yeah, gun logic is really split, like, 50-50 between, like, the gun has some logic, the bullet has some logic. So I'll talk quickly about the other gun types, and then we'll talk about the bullet types, maybe. We'll ignore this gun because it never made it into the game, although, again, it works, you can use it, it's just not fun. Slime gun, though. If the trigger is down, we start playing the sound effect, and we play it on a loop. And we ask it to fire. It fires every 0.05 seconds. Same fire delay logic. I guess that could have been encapsulated somehow, but it wasn't. Every gun just implements its own fire delay. And then we fire by spawning a bullet and calling fire bullet. Super simple. So this gun is, like, very almost platonic, right? Like, it just fires a thing every time, and in its bullet is all the complicated logic of how the bullet should behave. The scanner is more complicated because it's got this, like, feedback loop where it's scan ring. The way the scanner works, a scan ring goes out. If it hits something, it feeds back to the bullet, to the gun. I hit something, right? We have this on scan hit callback function that we set up. This gets called, feeds back. If it hit the same thing twice in a row and that thing was tagged as scannable, so using this global can be scanned function, which checks for, like, the scan tag, which we talked about. If it was scannable and we hit it, then we say our confidence factor went up. And that confidence factor means we, like, close in the rings, and we change the color towards blue. And so the way that's happening is every shot fired is fired with a confidence factor. The higher the confidence factor, the less open the rings are, the more blue the rings are. And so the feedback tells us increase confidence factor. Fire a more confident bullet, increase confidence factor, until we've totally focused in and scanned an item. And so like this is actually very like simulating what it looks like it's doing, which I think is nice. That like the code really does encode this idea of like the bullet goes out, it hits something. If it's the same thing over and over and it's scannable, it becomes more and more confident it's got to scan. And once it's fully focused in, it like lets you see the text you want to see. So yeah, that's here, right? If the confidence is greater than 100, we show the dialogue. We actually, the scanner, I don't know if anyone has noticed this. The scanner has a secondary way of indicating if a scan is happening. So if you look at the back of the scanner, it's filling up. There's 1 bar, 2 bar, 3 bar, and it'll pop up to 4 bars once you're fully scanned. 3, 4. And that's sort of also a secondary way that we show you scanning is happening, mostly because Mike drew the like art for those bars, and I wanted to make sure they made it into the game. So they fill up slowly. And then also the fire delay, I think gets shorter maybe? Yeah, so as you scan, it gets faster and faster to like fire it, so it gets tighter, gets bluer, fires faster until confidence reaches 100. So if confidence isn't at 100, then we increment confidence, we reduce the fire delay, and we are just doing a simple like floor function to figure out what number of scan pips we should be at. So what frame of the gun is what scan pip, like scan 0, 1 bar, 2 bar, 3 bar, 4 bar, and we just go from 0 to 100, meaning 0 to 3, then we take the floor. Okay. Cool. And then that's the guns, but then there's the bullets. We're jumping back into entities for bullets. Scan fire. Yeah, this is the complicated one, because there's the outer ring and the inner ring. The outer ring grows over time, the inner ring does not. There's some logic in the process function to oscillate both of them, so set scale pulse, and that's just scaling those rings, and this is that oscillation logic that makes the inner ring bubbly, kind of. Once it hits something, it goes into this dying state, and it tweens itself to 0, so once it hits something, it sort of fades out. It moves and collides, which is how it knows if it hits something. Unlike the player who moves and slides, it wants to just know, I hit something, I'm going to stop here and like fade out. Needs to know when it's spawned, because these like self-destruct, the range on these isn't very long. They like fade out on their own after they get more than like 15 units away or something. After they've been alive for 0.75 seconds, they fade out. Yeah, and that's kind of the deal with these things. I don't have a lot else to say. I did add this helpful color from... No, that's built in. Never mind. But yeah, if you want to like play with colors, it was frustrating to lerp from the red color to the blue color, but that logic is here if you like care about it. Because colors wrap around, right? So like they start at like 0 to I don't know, 0 to 255, but if you're like 240 and you want to lerp from 240 to 12, you need to like lerp over the top of the color spectrum and then lerp back up from the bottom to like slowly interpolate between two colors. That was a little bit odd. Anyways, that's kind of where the scan fire is. The other bullets are, like I said, less interesting. These do, when they hit an enemy though, they have interesting behavior, right? So if they hit something and they're not already like beginning to fade away because they're dying. So a bullet dying means it's in the process of fading out but hasn't been deleted yet. So we want to track that so they can't like hit something again once they've already like started to fade out. So if they hit an enemy, they call apply stun on the enemy. And then they also call back to the gun, hey, my on hit something, which is what triggers this callback on scan hit, right? We call it here. If it's valid, yeah. So yeah, if it hit an enemy, we apply stun. If it hit anything, we do the callback. No matter what it hit, we start dying. If our time has been up, if we've been alive for too long, we start dying. If we're dying, we tween ourselves out of existence. Cool. that's the scanner. Slime ball, I don't have a ton to say about this. Despite, like, we've talked through it mechanically, I don't think I need to read you every line of code. They release a particle when they die. They release a yellow particle when they hit an enemy. And that's the slime damage is the yellow particle. No. Yeah, slime damage is the yellow particle, I think. Nope, it has one particle emitter for when it hit the ground. It has one particle emitter, which is yellow, when it hit an enemy. I just thought yellow would be like a good sickly color. I don't know. So yeah, that's kind of the bullets. They tend to play back and forth with the gun. And then the actual bullet class just has a speed property, I guess. That really never got utilized very much, but all the bullets do extend this parent bullet class. So that's guns, that's player. Let's take a quick break. My throat is quite dry, and then we'll talk about enemies, and that's going to include behavior trees and nav meshes. And then I think we can talk briefly about menus, but beyond that, we're very close to being done here. So thank you for your patience. That's the end of the first code review session. There's going to be another video after this covering other aspects of the source code, as well as how to work with Blender and Godot together, and how I made some of the 3D assets in Blender. I hope you found this interesting, and I hope you'll continue on to the third video. Thank you so much for watching. Feel free to, contact me with any questions you have. Play the game, check out the source code. Have a nice day. Or don't. I guess that's your prerogative. Bye.